So let's introduce the capacitor in an AC circuit with E0 sin omega t variation, instantaneous current as I and the capacitor of capacitance to be C. Now let's apply Kirchhoff's law to this particular circuit. So we can equate, and by the way, this is nothing but the entire voltage across the loop should be equal to 0. So E0 sin omega t, I can equate it to Vc. But we know that voltage across a capacitor can be given by this. So we have E0 sin omega t is equal to Q by C. Now we want current. How can I get current from this expression? How can I get current from this expression? Yes, by differentiating with respect to time, right? So what will we get? This is nothing but current, right? dq by dt is current. C E naught omega cos omega t is what we'll end up with. Is it not? Reason dq by dt is nothing but our current. Okay guys, so I can write this better. Just a second. Let me do that. Now, differentiating with respect to time, we end up with dq by dt, which is equal to C E naught omega cos omega t. But again, remember, we need to express in terms of sine over here, right? So I, which I can equate it to I naught sine of pi by 2 plus omega t. This is how we can rewrite. Reason being, sine 90 plus theta is cos of theta. Okay, and one more thing we are doing, we are calling I naught as C E naught omega. Okay guys, so as per this, what is that we are looking at? If this is your voltage, the current will lead it by, yes, it's going to lead, the current is going to lead the voltage. This is omega t. So if this is our graph of, say, your voltage, that's where E naught is present, our current will look like this. It will already would have started off, and okay, not exactly right. Oh yeah, sorry, my bad. This is supposed to be there. So this is your I naught. That's your E naught. Need not be same, magnitude, but yeah, just representing it. So this is how basically it would look like. Does it make sense? One last thing. Here I wrote sine 90 plus theta as cos theta. Actually, we also have sine 90 minus theta as cos theta, right? So why not use that? That's one question that came to my mind and I wanted to tell you guys. So it's quite simple actually. Cos omega t is pi by 2 minus omega t. If I do take this up, we need to finally express in terms of sine omega t minus or plus pi by 2. For this, I need to take negative out. Why is that? Sine of minus theta is minus sine theta. So from here till here, what is that I'm doing? I'm taking out negative common. So negative 1, I'm taking it out. So I'm taking out negative 1 common. And where will that go? It will go outside. And so basically we will express in this manner. But what does this mean? We have something which looks similar to our conductor. Sorry, not conductor, inductor. So why not just continue with this? Well, this negative sign actually indicates that they're going around in, this is clockwise, this is anti-clockwise basically. Wait, they'll be going around in clockwise, the other way around. That's what the negative sign indicate. And here too, the current will lead. Current will lead because if I go the other way around, minus pi by 2 mean it is lagging the other way around. So basically, my current will be this side because it's rotating this side. So in that way, the current will be leading, is it not? Right? So technically, the two will be leading scenario. Let me take a second and show it to you guys. Okay, let me show this. Herein we have current, or sorry, your phases going round in this way, that is clockwise. Herein it is going, sorry, this is clockwise, that is anti-clockwise. So if this is current as per this diagram or this equation, here the voltage will be behind the current by 90 degree. So this is how it would be. Minus 90 means this way. That's minus 90 for you guys. Okay, does it make sense? So basically, this also shows the same thing, just that it is the other way around. That's it. Okay, so yeah. So let me put it this way. Actually, let's conclude properly. I didn't talk about the conclusion. See, what we're trying to do here is trying to see how the current behaves in presence of a AC circuit and a capacitor. So what we concluded is current leads. What does it mean? The peak of the current comes before the voltage. Voltage is peak. Let me show that in terms of a moving graph. Right guys, so here we are looking at the voltage leading the current, right? This was your inductor's behavior. Okay, look at the graph also here as well. So here the red peak happens to be before the blue peak, just before that. The difference between them is 90 degree, the phase difference. Now, if I want the current to lead, so it would look something like this. So here the current is in lead. You can see the blue comes before the red. So basically, this is your latest. This point to the rightmost is your latest. So the peak, observe the peak and the peak of the red and the blue. Peak of the blue came first and then the red. In this case, it is leading. A bit of code I can change and I can make it go round, wherein you will have this particular expressions scenario. Right guys, here it is, how is it rotating? It is anti-clockwise. If I change the sign and all that, it will become clockwise, and that in that case it will be minus 90. This expression will be minus 90. Okay guys, I hope that is something that made sense to you guys. And now you guys have to copy this up.